Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss the concept of effect of acceleration in suction and delivery pipes on indicator diagram. So in our last lecture, we have discussed about the indicator diagram, and in the indicator diagram, I told you that it will have variety type of concepts are there. So in the last lecture, we discussed about the ideal indicator diagram. So this is the second category, that effect of acceleration need to be considered during the suction and delivery pipes in the indicator diagram. So the last indicator diagram what we have discussed, there we have seen all lines are like vertical, otherwise horizontal lines are there in the pressure head. But here we need to consider the acceleration effect in the suction and delivery pipes. By considering this acceleration effect, we'll have different kind of diagrams. So this diagram we got in this finally here for the indicator diagram. Okay, before going to this indicator diagram, just I'll give a hint about the working principle of that reciprocating pump, how it is working. Then we'll come to this graph. So we know that indicator diagram is the comparison between the stroke length of the cylinder, like inside the cylinder, and with respect to the pressure head. So pressure head will be there in the y-axis, and the stroke length of the piston inside the cylinder, this will be in the y-axis, sorry, x-axis. Okay. Now, before starting this one, let me just give a hint about this, like how it is working. So we know that we have a, suppose this is the reciprocating pump is there, and this is the pipe, and this is our delivery pipe, and this is the cylinder is there. Inside the cylinder we have the piston, and this is the suction pipe. The suction pipe is connected to the sump or the reservoir, what we can say. This is our delivery pipe, and here the delivery valve is there. This is our delivery valve, and here one valve is there, that is a suction valve. Okay, and this is our suction pipe, and this is the sump label. This is the sump, and the atmospheric pressure is working on this, so P atmospheric. Okay, so this is our cylinder part. Inside the cylinder we know that we have a piston is there. So this is the piston starting point, you can say inner dead center or starting center of this piston. Okay, and the piston is connected with the help of piston rod, and this piston rod will be connected to the crank with the help of this connecting rod. So this is our connecting rod, and this is crank, suppose, and this is our direction of crank. Okay, so these things already we have discussed, just I'm giving again a reminder to you like how it is working. And this is the closed part of this cylinder. This one you can mark it the cylinder, and this is crank, and this is, yeah, this one is piston, this one is piston, and this is our piston rod, and this is connecting rod. Okay, now this is the starting point. So suppose this is the left side and this is the right side. So at this point, starting point, the piston is supposed to move to the right side. So that means we can say this is forward direction. Now the piston, suppose at the left side is there, and the left side the piston is present and is supposed to move to the right. That means the piston is moving forward direction. It is moving forward direction, you can say. So in the forward direction, if it is moving, then this crank will be like how it is working. The crank will be connected to a motor. So once you switch on the motor, the crank will be started rotating. Once you start, the crank will be started rotating. So it will move like this. So this is the first step. Then the crank will be moved to here. Okay, then crank will be like up to 90 degree. It will be here. So when the crank will be from this point to this point, it will be when it move 90 degree covering. Then by the meantime, this piston also will be moved from this original position to at half of this part will be covered here. So the piston will be moved to here, like from this position to this position. So we can give, suppose this is our A point, this is center point O. So when the crank is rotated, this is the rotation, omega rotation will be there, angular velocity. When the crank rotated from A point to B point, okay, that means that piston covered a distance of, suppose some x distance or x1 distance covered here. Again, the piston will be covered from this point to up to the end, right side of this. So when it is covering fully, like from this end to other end, that means it will reach to the at this point. So this point we can give a C point. So that means that initially the piston was a 0-degree angle, and at the middle of this part we can see it is reached to a 90-degree angle, and at the C point and at the right side. So here suppose if you take 0-degree, in middle it is 90-degree, and the right side we have the 180-degree total right side. So that means C point. So at this point we can give 180-degree angle. This is forward direction. Again in the backward direction, what will happen? From right to left it will move. From right to left in the sense from C to D, A point through D point. Again we can see C to D point. This is D point, that is 270-degree angle. So if I see, this is our 180, this is 270, again this will reach to 360-degree. Again it reaches to the A point. That means the piston started from the right side to and moved to the left side. So this forward process or this forward movement is nothing but our suction stroke that we have discussed, the suction stroke. And the reverse stroke or the backward, this one we can say this is our backward movement, or this backward movement we have taken delivery stroke. So these things also I told you in our last lecture. So what is the difference then? So in the last lecture what we have discussed, that is ideal indicator diagram. So in the ideal indicator diagram we have not considered the concept of acceleration part, because in the previous lecture of one derivation we have done, and there we got the pressure head due to the acceleration in the suction and delivery pipes. So what equation we got there? That is the pressure head due to acceleration in the suction pipe, HAS. This equation we got, this is LS, length of the suction pipe divided by G into area of the cylinder, and this is area of the suction pipe, and this is omega square crank movement, and this is R into cos theta. This is for the pressure head due to acceleration at the suction pipe. Similarly, we got another one equation, HAD. This is pressure head due to acceleration at the delivery pipe. This one. So what equation we got here? One is suction and one is delivery pipe. So here also we can write, this is the length of the delivery pipe. This is G, and area of the cylinder. This is area of the delivery pipe, and this is omega square into cos theta, R into cos theta. So these are the two equations we got in our previous lecture. Okay. So what you can understand here, that means the effect of acceleration is there at the suction pipe as well as the delivery pipe. But in the ideal indicator diagram, we have not considered that. In the ideal indicator diagram, we have done this diagram, A to B, again B to C, and again C to D, and D to A. We got this kind of diagram. So when there is a concept of acceleration in the suction pipe and acceleration in the delivery pipe, with the effect of this acceleration at this moment, so we need to consider that for both the cases. So for both the cases, like you can see, when this water will be started sucking here, so along with the suction head, we have a acceleration also will be there. Pressure head due to the acceleration, that is HAS. So this also will be need to be considered here. Okay, before going to this concept HAS and HAD, okay, one more term I just tell you. In this equation, this is our equation we got previously. Okay, equation number 1, and similarly equation number 2. So in this equation, if you see, as I told you, 0 degree, 90 degree, 180 degree. Okay, this is our equation. Suppose when the theta equal to 0 degree. So at that point, cos theta, that means cos 0 we need to keep. So cos 0 equal to, we'll get 1. So if this is the value 1, then we'll get HAS equal to how much we'll get? Let me write, HAS equal to, we'll get just LS by G into that's A by AS into omega square R. This is the at theta equal to 0 degree. And similarly, let's find out when theta equal to 90 degree. So theta equal to 90 degree in the sense at this middle of this point. This is angle theta. Okay. Now when theta equal to 90 degree, we'll get the value of HAS, this equation. Again, what is the value of cos 90? Cos 90 equal to 0. So we'll get whole term will be 0 here. Okay. Now the next one, when the piston will be reached at this point. At this point you can see the pressure head due to the acceleration at this point is some value will be there. But when it is 90 degree at this middle of this part, at that point we don't have any kind of pressure head due to the acceleration. Similarly, when theta equal to, we will consider 180. That means what is the value of cos theta? Cos theta will be minus 1. Here, when theta equal to 0, we can write this is cos theta equal to 1. And here this is, we can write this is, not this one, this is cos theta equal to minus 1. This is minus 1. So minus 1 means what will get here value? HA is equal to minus of LS by G, okay, into A by AS into, this is omega square R as usual. And here I'll just write cos 90 equal to, this is 0. I hope you understand. Just I kept the value of theta in this equation and find this value. Now why I told this one? Because I'm going to explain about now what is the role of this pressure head at the suction due to the acceleration in the suction pipe, and as well as in the delivery. Once you understand the suction pipe, similarly delivery pipe also you can understand easily. Now we have seen previously that atmospheric pressure head is more than the suction head, because the atmospheric pressure head is acting. If you see, this is our center point. So acceleration pressure like the pressure head due to the atmospheric pressure here at this point, H ATM. This means the total height. Or so how we got this value H ATM? So we know that P equal to rho G H. If you want to calculate the value of head, see, this is only pressure value. When you talk about the pressure head, then at that time we need to consider H equal to P by rho G. So this P by specific weight, that is we can convert into pressure head. Okay. So H equal to P by rho G. Now this is the value, this is the H ATM in the sense pressure head at the atmospheric condition. Okay. Now here what we got here, some acceleration effect is there at the suction pipe. So the pressure head inside the cylinder, see the pressure head inside the cylinder, that means during the suction stroke, if you see, okay, which will be not equal to only HS value, which is not equal to HS value, because HAS is there. So in that case, so in the ideal case we have taken only HS, that's why it got only the straight line we got here, constant pressure head. Okay, but here it is not like that. Here we need to consider the HS plus HS. So what we'll get here, we need to consider HS plus HAS, because at the beginning of the suction stroke, if you see at the beginning of the suction stroke, theta is how much? 0 degree. Theta is, if you see at the beginning of the suction stroke, where the suction stroke, this is the suction stroke. At the suction stroke, what is the theta value here? 0 degree. Correct. So at the 0 degree, what is the value of HS? What the value of HS here? If you see, some positive value we got here. Okay, some positive value we got here. So due to this positive, we can say the pressure head in the cylinder can be taken as HS plus HAS. Okay. Obviously, this will be below the atmospheric pressure head. Okay. So this is first point. Second point, so that our point initially during the ideal indicator in diagram, we got this point here. But here the point will be started at this point, A dash point. Okay. So ABCD is the diagram for the ideal indicator. Now the diagram what we consider here, we need to start from the A dash point. So A to A dash point, this is AHS. That means the pressure head due to the acceleration in the suction pipe. So that is, we need to start from here. This is at the theta equal to 0 degree. Now the next one is what? The next one is theta equal to 90 degree. So during the theta equal to 90 degree, what is the value of HS? Okay, so at the theta equal to 90 degree, that means at the middle of the pressure, at the middle of the cylinder we can say. Okay, so middle of the cylinder in the sense at this point, middle of the suction stroke you can say. So this is the suction stroke. So suction stroke middle, if you see, the middle of the suction stroke is this one. The G point is given here if you see. So at this point theta equal to 90 degree. So 90, what is the value of HAS? 0. Okay, so this value what we have taken here, suppose if you have taken this positive, here we will get 0 value. So the point will be at this point. Now the next one is what? So theta equal to 90 degree, we got this HA is equal to 0, and this is the pressure head in the cylinder will be at this point, G point we can mention it. The next one is when theta equal to 180 degree, that means when this piston reach to the right side fully at this point. So total distance how much covered here? X. So here also the total one stroke covered here, half of the revolution completed from 0 to C, 180 degree. For the 180 degree, what is the value of AHS value? We got some negative value because cos theta equal to -1, we got cos 180. So we got a negative value here. Okay. So this negative value will be give us here HS minus HAS. That means the value will be goes up here. This is the HAS you can see here. Here HAS is positive, here HAS is negative based on the equation it is giving. So, and this also will be below the atmospheric pressure head. Okay, so for the suction stroke, if you see for the suction stroke, the indicator diagram will be shown here. Like if you see which point, like A dash point, G point, and the B dash point. So for the suction stroke, you can write for the suction stroke, the indicator diagram is A dash, G, B dash. Okay, and along with that, if you see this area, this A dash AG, okay, the area of, we can say the area of A dash AG, this area will be equal to this area. Okay, that one what? That one also we can write B dash BG. So this area equal to this area. So this is all about the suction stroke. Okay, and yeah, stroke length I hope you understand, because the stroke length is nothing but what is the length of piston is covering inside the cylinder and how much stroke is giving here. So that is nothing but LO is to consider. Anyway, that also I told you many times, you can understand here. This is about the suction stroke. Similarly, if you see the delivery stroke, in the delivery stroke also same thing, like let the position will be now changed. So here C point and this is D point. So here HAD, here HAD, and here if you see HAD is here. Now this HAD how it's moved, because see C to B point that is fixed. So like when the piston will be moved again from this point to in this backward directions. Okay. So in the delivery stroke, okay, at the beginning of the delivery, if you see HAD is positive again. Beginning of the delivery stroke, HAD is positive. So HAD equal to positive. Okay. So what do we need to consider here? Delivery strokes need to be considered HD plus HAD. HD plus HAD, and which supposed to be above the atmospheric pressure head. Okay. And similarly, the next one at the middle of this delivery, again it will be like HAD will be 0. HAD will be 0 at the middle of the delivery stroke. So that will be reached to the at this point. Okay. So this is C dash point, and this is middle of the point you can see. So that is HAD equal to 0. And next, the last one if you see. So at the pressure head in the cylinder, that will be equal to HD. This is nothing but how much distance will be there from here, that is HD. And this is HS. So these things I hope you understand, because I have not mentioned here. Let me mention it here. This is HS and this is our delivery head. This is HD. Okay. So once the delivery end is going to be complete at the end of the delivery stroke, okay, so HAD will be negative. HAD will be negative. Okay, how it will be, how we can identify? Let take this value. If you consider again, okay, so we'll get the same value here. Okay, so HAD will be negative at this point at the end of the delivery stroke. So due to that, we can write HD minus HAD, and that will be obviously, if you see this point, which is also above the atmospheric pressure head. So what is the delivery stroke is acting here? So if you see C dash H D dash, this is the line C dash H D dash. This is the line for delivery store. Previously, what was there for the ideal condition? CHD. CHD. Now what we got? C dash H D dash, because of this consideration of acceleration at the delivery point, delivery valve. Okay, delivery pipe you can see. And what is the area of this? Again, same thing, C dash H. Again, we can write C dash H. This area will be equal to D dash H, this area. So area of this side will be equal to area of the other side. So previously, again I'm telling you, ABCD, if this is the line was for the ideal condition, this is the ideal indicator diagram. But when we have considered the acceleration effect in the suction and delivery pipe, because from this formula we can understand, okay, the effect of acceleration is there at the suction and delivery pipe. Due to that, now it changed to A dash, B dash, C dash, and to D dash, converted to this one. Okay, so this is the concept. But similarly, the area of the indicator diagram also, this will be equal to this. This is for ideal and this is for acceleration. Similarly, we can write here area of ABCD equal to area of A dash, B dash, C dash, D dash. Okay. So finally, what I can conclude here, so the work done by the pump on the water will be same for this condition. Okay, so this is all about the effect of acceleration in the suction and delivery pipes on the indicator diagram. I hope you understand. Still, if you are having any doubt and query regarding this, you can give a comment on the comment box. Thank you all.